This topic is one which deserves a lot of intelligent thought and a lot of careful consideration. And I know that everybody in the audience over here is very intelligent and has done careful consideration and has probably read a lot about this topic. So I'm not going to be trying to pull any rugs out from underneath us. I'm simply trying to arrange ideas in a particular idea that's worth thinking about. The reason why this topic appears right now is because it used to be that in the Regents for 9th grade, it used to be that the evolution unit was an elective. Happens to be that it is no longer an elective in the Regents curriculum, which means that 9th grade kids now have to learn about evolution. So in the school, I teach in high school, I teach in 9th grade in Shulamis High School, and the biology teacher came forward before the end of last semester and said, look, I'm going to be teaching my next unit on evolution, and I want to make sure that we don't just leave the girls floundering. Maybe we can address the issues that they might be in the back of their minds. And so together what we did is we sat down and we devised. I went through her lessons, she went through my lessons, she actually sat in during the classes, and we took a quick week off to address the topics. And I thought that was actually a very important process, because you're leaving young minds who are now left to flounder or to think or to consider ideas and concepts which they may not have the tools and sophistication necessarily yet to be able to think about, which sort of spurred myself into this particular topic, because I spent a lot of time reading about this years and years ago. I'm fascinated by the topic of evolution, but I never really formally put anything together about it. So what I did was, because of school, I started putting things together. Now this is the more advanced version of this particular topic. So before we even get into this, it's important to just give everything its due space. Meaning, people get very heated about these particular topics, and in both directions. It's important to consider everything slowly and carefully without getting too excited about everything, piece by piece. So first of all, before we even understand what trying to deal with evolution, what is evolution? Is number one. Is the first question on the table. So just as a very, very basic outline is the following. Is what we do is we have observations, scientific observations as to what we see today going on, and from then we extrapolate a theory as to what happened. So observation number one would be that there are many different species alive today. Okay, so that you look around in the world, and that's a pretty innocuous observation. Is that we look around, and there are many different types of animals, and they are, whether it be in terms of the fauna or the flora, there's an incredible dearth of species, of sophistication of different types of animals and plant life, and that we see around today. Then then we also notice that all life shares common characteristics. So whether it be on a cellular level, whether it be on when you consider the body as a whole, there are lots of very similar things that life has. So on the one hand, there's a lot of diversity when we look at the world today. On the other hand, there's a lot of common shared properties of organisms. Furthermore, we know that Earth and life is very old. So meaning to say that based on the tools of our measuring, which used to be carbon dating, which is now radioactive dating, we know that there's a lot that according to the tools that we're measuring, which is a relative scale, of course, nonetheless, it seems that we have a lot of time to deal with, which is going to be an interesting thing to consider. And finally, we look at the fossil record, and we've discovered more and more fossil records. The fossil records show, number one, that there are a lot of creatures that used to exist that no longer exist, right? And also, what's interesting about the fossil record is that there's lots of similarities between some of the creatures that used to exist and the creatures which do exist. One example, what we call is a vestigial organ. So we'll call it, let's say, a useless organ in an animal. So we look at the fossil record, and we see that the whale or any creature from that particular line of animals has a ankle bone. Now generally speaking, the way that isn't very useful for the whale. The whale's not doing too much walking or paddling with his ankle bone, and he's also got a pelvis which is similar to the mammals, which is again we'll call a useless piece of the whale's body, which indicates that maybe there's a connection between some of the things that did exist, some of the things that do exist. Maybe there's something that's going on. Now notice that all of these things are simply observations, meaning this is not a theory. This is when you look at life, I think we could all agree that this is true. The question of the earth being old is a question. There's a little bit of a question in terms of the tools of measurement. But, on a very simple level, everything we see over here is what we see and what we've discovered in the last 150 years. So, what we do is we take the observations, and the theory of evolution is we take that let's actually go back. In the 1850s already, and a little earlier than that, Charles Darwin went to the Galapagos, and he discovered that he did a lot of research on finches, and he found, not just finches, but other birds, and he found that each island had a different type of finch, slightly different. This one had a longer beak, this one had different lengths of wings, and he found that, in fact, that it must have been that there really was one original finch, meaning there was one original finch family, and as that finch got distributed among the different islands, they adapted, so to speak, to the different climates, and to the extent that certain finches on one island couldn't even mate with ones on the other island, almost, which might be the definition of a difference in species. So you see that something must have been happening. There was a common ancestor. So the first idea of evolution is common ancestry, which means to say that everything really comes from one place. Really, 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 if you go back all the way back, everything comes from one place and explains two things. It explains, first of all, the unity of life, why everything has the common similarities on a cellular level and even on a bodily function. There's similarity between all living things, and also explains the diversity of life, because evolution explains that there's a wide variety of creatures on Earth which developed based on circumstance, environment, and a particular mechanism in just a moment, that we have now the diversity of life coming from one source. So evolution simply is a very simple argument. Number one is that there is common ancestry. Everything came from one place. All animals you see, including you and me, that's where it becomes a little sticky. All come from the same source, right? Everything was over a long period of time developed. How did this actually occur? So the mechanism. It's important just to differentiate between the mechanism and the theory. The mechanism that Darwin suggested is called the survival of the fittest, or natural selection. Natural selection is the following. So, the example that's many times given is, let's say you have a whole population of mice, right? And so what ends up happening is, in general populations, there's something called random mutations, which means, this one looks a little different to that one. That just happens, right? Meaning to say that some will be white, some will be brown, and let's say you have a whole group of mice. So it happens to be that their predator is let's say a particular hawk, and the hawk is hunting those mice. So it happens to be that the white ones are the unlucky ones, because let's say they're living on the prairie. The ones that are brown are going to be more camouflaged, and the white ones are going to be less camouflaged. So what ends up happening? So slowly over time, what's going to end up happening is the grey or browner mice are going to be the ones that survive, because they're the ones less hunted. And over a period of time, what's going to be left over is the population of mice is going to be predominantly brown or grey. Right? There's nothing revolutionary about that logic. And therefore, what we'll see is, this is what we call the process of survival of the fittest. Fittest doesn't mean the strongest or biggest. Fittest means the fittest for that environment. Right? So it could be a camouflage. It could be certain defense mechanisms that the animal has. But the ones that have the random mutations that help it survive in that environment are going to be the predominant gene. And slowly over time, that's going to be the animal. So now that survives and therefore takes on the name of that gene. So let's say you have a animal which has a slightly longer neck in the herd. It's going to be the one that can reach the leaves and the drought further, so there's going to be more of those animals which propagate than the ones with the shorter necks. So over a period of time, the longer necks are going to be the ones that survive. And slowly but surely, gradualism, there's going to be a change in the actual constituency of this particular phylum. And then what is also fascinating today, and this should not be omitted, some people do omit this point, is that on a biological level, on a bacterial level, we see it in motion. Meaning to say, since the last, it's been now almost 80 years where we've had antibacterial penicillin, and we've noticed that, in fact, that antibiotics and all the different types of antibiotics are effective in wiping out bacteria. However, it isn't effective in wiping out all bacteria. So we see today in labs, and we see it in hospitals as well, that there's certain bacteria which are more hardy, they can survive, they're able to have survival mechanisms against penicillin, and they become immune. So you think, oh, well, that's not a problem. The problem is that they're the only ones that survive. So they become the predominant gene in the bacteria, and therefore that becomes a surviving bacteria. Now we have evolution. We watch evolution actually happening in the lab, where we see this substantiated, which is now a very good indicated to say that, therefore, if you're looking back at the fossil record and you're saying, well, how did it get from, this particular creature to the next particular creature to the next particular creature? Maybe that's what happens. Meaning we weren't there to see it. The theory of evolution is saying, let's look back and say, well, the same thing that's happening on a micro level over here, and that which makes sense, and we see happening on a species or within a particular species, maybe that's what happened to get from one to the next, which helps us understand how we can have common ancestry. Right? So slowly over time, you say, well, it's going to take a long time. The answer is, there was a lot of time, because as of now, we're at about 15 billion years for the age of the planet, so we have a lot of time to deal with. So this is sufficiently plausible, which is the general theory of evolution. Fascinating, very interesting. This is a very coarse summary of what evolution is, but nonetheless, it is important to put all the factors into place. Something very important to bear in mind is some people say, it's a theory. After all, it's just a theory. Theory in scientific parlance does not mean to say that it's a conjecture. Okay, theory, like the theory of gravity doesn't mean to say that if you're going to jump from one side of the cliff to the other, you're going to hope that it's just a conjecture, because it works, right? The theory means to say that this is something which is proven, and this is widely accepted across the scientific world, right? So meaning to say that today this is the narrative in high school textbooks. This is what is being taught as evolution. So that's what we have. Now the question really is so what are the contradictions in terms of Torah? Meaning, does it have to be such a bombshell for Torah? So the answer is that it might be, on a textual level. Here's the creation of humanity. So there's two versions of creation. There's creation 1 and creation 2, Adam 1 and Adam 2. Adam 1 is Vayemer Elokim totzeh haaretz nefesh chaya lemina, behema v'remes v'chayis haaretz lemina vayhi chen. So on day 6 we have the creation of animal life. So God brings out animal life. Fantastic. That's Chaf Daled. Vayas Elokim es chayas haaretz lemina ve'es v'behema lemina. Each animal is created to its species. Ve'es kol remes adama leminayu vayar Elokim ki tov, and God saw it was good. What's the problem? What problem does that pasuk present before we even get to humanity? What's the problem with the way that creation is described in the Torah?
It wasn't from one to another.
It sounds like we call it static creation, meaning limineu means that there's specific species. God created species, meaning evolution is arguing that essentially there's common ancestry. Really, if you go all the way back, you can actually go to one life form. However, the Torah seems to say that there was a static creation of numerous species already from the beginning.
They're differentiated.
Differentiated species already at the beginning. Okay, so this seems to be, number one, an issue. Number two, we talk about the creation of humanity. Let's make humanity in our form and image. He will be in charge of the fish, in terms of the avian life, will be in charge of the rest of the creation. So what's the issue from this pasuk?
Again, it's an immediate creation.
Right, it sounds like we have once again an immediate, distinct and static creation. It sounds like humanity came into being when God decided humanity came into being. It wasn't that, as you'll see in the beautiful charts of the ape leaning over and a little further up, and Neanderthal man and prehistoric man, and then finally Homo sapien. It sounds like that the Torah's way of describing it is, no, it started at the very beginning. There was boom, one moment there was humanity. That's the way the Torah seems to describe it. Moreover, on the second parak, when it recounts creation, the actual organic content of human is described explicitly in the Torah. Vayitzer Hashem Elokim es ha'adam afar min ha'adama. So the pasuk says explicitly, no holds barred, that it is that what's going on. Where does humanity come from?
It's creationism.
It's creationism. It sounds like humanity. I want to be careful with that term because we don't want to sink the Torah into a particular theory. But what seems to be over here is the Torah seems to saying that the basic building blocks of humanity was in fact dust. It doesn't say anything about there being another. We'll call it God's taking another creation and infusing it. Doesn't seem like what I'm saying. Can we hold the question? Is that right? It was a question. Just want to build a little bit of inertia over here. So there's a textual level. Now, to be honest, if this was all that was at stake, there's ways we could understand this. We're going to next week in Mitzvah Hashem. We're going to spend a little bit of time trying to look at the bigger picture in terms of understanding what Bereshis is really telling us. If text was all that was the problem, then we could work it out. We could understand, we could analyze science, we could analyze the psukim and sort of see how the psukim actually work out. However, evolution isn't just a theory. You see, this is where it gets a little more complicated. Evolution is actually also an agenda. You see, because here's how it goes on a philosophical level. Here's the thoughts of William Paley. So we're living now we're in the 18th century, and listen to this experiment. You tell me what the name of this paragraph is. He says, in crossing a heath, suppose I pitched my foot against a stone, and were asked how the stone came to be there. I might possibly answer that for anything I knew to the contrary, it had lain there forever. Nor would it perhaps be very easy to show the absurdity of this answer. But suppose I'd found a watch upon the ground, and it should be inquired how the watch happened to be in that place, I should hardly think of the answer I had before given, that for anything I knew, the watch might have always been there. There must have been, there must have existed at some time and at some place or other an artificer or artificers who formed the watch for the purpose which we find it actually to answer, who comprehended its construction, design, and use. Every indication of contrivance, every manifestation of design which existed in the watch exists in the works of nature, with the difference on the side of nature of being greater or more than that in the degree which exceeds all computation. By the way, just an interesting point over here is the watch over here was just actually entering society. Because remember, there was at this point in time, we're talking the 1800s, there was a large battle between in trying to discover longitude. I mean, to say how could you discover how far across the world you were? And this has created many problems, because you could work out latitude very easily, but longitude was a bit of a problem. So when you're going across the sea and you didn't know how far you were, that's a lot of problems in terms of rations. There's a lot of issues. There were two camps as to try to understand this. There were the people who were looking to the skies to try to work out with very complicated systems, and there were the watchmakers. The watchmakers were the ones who, if they could create a watch which was sophisticated enough and balanced enough that could keep time to the second, and we take it for granted, but if it could keep it to the second, you could work out how far across you were based on where the sun was at midday and the time that the watch was telling from the port that you left. And so as this is the time when the watch is being developed as this most sophisticated next step in terms of technology. So and by the way, the watchmakers won, despite the fact that they were cast aside by the science of the time, because the astronomers were not very excited about the watch. They felt that it was unscientific. Nonetheless, so when he's talking about a watch, we're talking about the most sophisticated invention of the time, and when you look into a watch, we take it for granted the cogs that are moving. So he's saying, you imagine, the wind blows, this cog in this direction, this piece of metal over here, and then suddenly, all of a sudden, it all comes together. So it's impossible. This is what's called. What's the name of this theory? This is called.
Watchmaker.
This is the watchmaker proof, which is the formulation of a much earlier proof. William Paley was not the first person to say this. But in the terms of the example he gave, this is called the watchmaker proof, which is called proof by design. Which means, how do you find God in the world? Look at the world. The world is so much more sophisticated than a watch. The world is so much more sophisticated than a watch. How could it be that it all came together? Like just as an example, if you watch BBC Planet Earth, they definitely have an evolutionary agenda. But nonetheless, if you just take the facts themselves, it's very fascinating. Like, you have these remarkable things. You go to Brazilian rainforests, and you have there's a particular fungus which infects insect populations. So let's say it's an ant colony. So there'll be a plant will release a particular fungus which will infect an ant. The ant which is infected looks like it's walking around drunk. It walks up to the closest bush, goes up to the stem of the bush, and puts its pincers on the bush and dies. And then the fungus grows to the back of its head like an alien growth. You've never seen anything more remarkable. As it grows to the back of its head, releases spores onto the rest of the ant population, which infects more further ants. And they discovered that the reason why this is happening is because when there's overeating, meaning when the ant population becomes too large, the defense mechanism of the plant kingdom is to infect the insect population. It's a culling process to keep the balance of the ecosystem. I mean, that's really incredible. You look at the sophistication of the eye. The iPhone 6, which lasts for a full 18 months before you need to replace it, it doesn't have the sophistication of your eye. Just think about when you're in a dark room and you switch on the lights and you watch your pupil enlarge and contract. We have a number of ophthalmologists in the room in the shul. That the sophistication of the eye, which we're trying to approximate with these little machines, which last for much less than the eye does, is remarkable. So says William Paley, and many of the Rishonim long before him, is that it must be that there's a God. So the problem is that he ended his works in 1805. Okay, so comes along in the next. Who's this gentleman with the beard over here? This from looking fellow. His name is Charles. Okay, so Charles over here, Charles Darwin actually lived at around just at the end, going in now into the 19th century. Remember, everybody seems to have beards in these days. Okay, so everybody looked, had the right face for this. And this is what he says in his autobiography. Remember, he came out with The Origin of the Species, which was actually not the first of his books, but in 1859. He says, although I did not think much about the existence of a personal God until a considerably later period in life, I will here give the vague conclusions to which I have been driven. The argument of design in nature as given by Paley, which formerly seemed to me so conclusive, fails. Now that the law of natural selection has been discovered, we can no longer argue that, for instance, the beautiful hinge of the bivalve shell must have been made by an intelligent being, like the hinge of the door of a man. There seems to be no more design in the variability of organic beings and the action of natural selection than in the course which the wind blows. Everything in nature is the result of fixed laws. You see what's happening? Evolution is not just simply a theory. What happens with evolution is that you look at God, you look at the universe and say, where's all this complexity coming from? So Charles Darwin would say, well, there's a process. Meaning, how did it get there? Over a lot of time, there was a lot of organic mutation, and there was a lot of survival of the fittest, and that's how we got to the sophistication we have here. There's another answer to the watchmaker theory. You see what's happening over here? The argument about design is slowly petering out because of the fact that evolution is now the answer to the sophistication. Just so you should appreciate that we weren't the only people in religious angst at the time. Here is, let me see if we, Baron Alfred Tennyson, who was the poet Laurel in the Royale in the Victorian era. This is in a poem called In Memoriam. Later on in the poem, very sophisticated poem, beautiful. Listen to the stanzas. So careful of the type, but no. From scarped cliff to quarried stone, she cries, 1,000 types are gone. I care for nothing, all shall go. What's he talking about? He's right. This poem was finally published in 1850. What's he talking about over here? So careful the type. What does he mean type? Type over here is species. So I mean, you say, we thought that nature was so careful of the type. Every living being was so special to God. Right? He was a very religious man. A religious Christian. So careful of the type. God was so careful of every species. But no! Meaning what's happening? What's evolution arguing? No, it was just one big war out there between different living organisms. From scarp to cliff to quarried stone, she cries, 1,000 types are gone. What's that? The fossil records. 1,000 types are gone. There's been distraction. There were animals which no longer exist, which means there wasn't particularly a purpose for them, perhaps. I care for nothing, all shall go, meaning there's no more purpose in anything. Thou makest thine appeal to me, I bring to life, I bring to death. The spirit does mean but the breath. I know no more, and he shall be, and he shall he. Man, her last work, who seemed so fair. Now we're going to humanity. Such splendid purpose in his eyes. Who rolled the psalm to the wintry skies. Who built him built him fanes of fruitless prayer. Who trusted God. Who was love indeed, and love creation's final law. Though nature red in tooth and claw, with ravine shrieked against his creed. What's he saying? Nature red in tooth and claw. That's survival of the fittest. You see what he's saying? Meaning, you see what as a religious human being, he's struggling, he's shouting out against what's going on. I believed humanity to be this divine creature, to be this divine, unique being. And now what's nature telling me is, no, it's all just, nature, red in tooth and claw. Very famous quote from Lord Tennyson. Is, no, you know how we got here? It was just, we were the biggest brute, we were the fittest brute to get here that survived through the Neanderthals. And he goes on. And he goes on at the end, who loved, suffered countless ills, who battled for the true, the just, be blown about the desert dust or sealed within iron hills. And his conclusion, listen to the struggle the man is having. O life as futile then as frail, O for thy voice to soothe and bless. God, what hope of answer or redress behind the veil, behind the veil? He doesn't know the answer. Do you understand? This is the 1800s. This is published 1850. Okay, so people are really struggling with what evolution is not just arguing, but replacing. Take it one step further. Richard Dawkins. Richard Dawkins has a book called The Blind Watchmaker. Okay, it's specifically about Paley. And in his book, Richard Dawkins is one of the preeminent, he's in Oxford, he's one of the preeminent scientists who professes evolution today. I won't go so far as to say he's like Donald Trump, but anybody who argues with him suffers from his very, very sharp criticism and sarcasm, even friends in his own camp. And he, in this book, he argues in the following: Paley's argument is made with passionate sincerity and is informed by the best biological scholarship of his day, but is wrong, gloriously and utterly wrong. The analogy between the telescope and the eye, between the watch and the living organism, is false. All appearances to the contrary. The only watchmaker is nature, is the blind forces of physics, albeit deployed in a very special way. A true watchmaker has foresight. He designs his cogs and springs and plans their interconnections with a future purpose in the mind's eye. Natural selection, the blind, unconscious, automatic process which Darwin discovered and which we now know is the explanation of the existence and apparently purposeful form of all life, has no purpose in mind. It has no mind, no mind's eye. It does not plan for the future. It has no vision, no foresight, no sight at all. It can be said to play the role of the watchmaker in nature. It is the blind watchmaker. This is his argument. He believes, and he argues very vehemently in this book and in other writings, that in fact, it is clear that there is no God because of evolution. There's nothing to talk about. There really isn't. Another example, evolution has no long-term goal. There's no long-distance target, no final perfection to serve as criterion for the selection, although human vanity cherishes the absurd notion that our species is the final goal of evolution. That's, he's got a pretty big axe to grind when it comes to these things, and he's not shy about saying what he has to say. One of the other real leaders in evolutionary thought very recently was Stephen Jay Gould, who we're going to discuss, God willing, next week, who equals him on a scientific level and the advances that he brought about in terms of evolutionary biology, but couldn't be more different in terms of personality and humility. We're going to deal with him a little bit later. He's really one of the preeminent atheist biologists. And actually recently, just a few years ago, Rabbi Jonathan Sachs had an interesting debate with Richard Dawkins. Really worthwhile taking a look at if you have a chance, about the role of science and religion, which is what we're going to be talking about next week. So here we have it. So we have a little bit to talk about, right? There's getting to this point. That's a little difficult. So here we are. There's two ways of looking at it. There's many or more ways you can subdivide this into numerous different subcategories. I want to just be very simple about this. There's the questioning the science, meaning to say dealing with the contradiction, and there's synthesis. So rather you can get into synthesis, rejection, revisionism. Right, there's all types of categories you can create for this. I want to just today spend a little bit of time in questioning the science. Okay, the people who did. So first of all, let's take a look at priorities. The Lubavitcher Rebbe wrote a letter in 1961. The person who was sending him a letter was asking about the age of the universe, and this letter is actually compiled and found on Chabad.org. It is available to all to read. Very worthwhile to read. Very sophisticated in terms of the arguments that he makes. But he makes a very important point. And this is in the second paragraph. And I'm not going to read it inside right now, but his point is the following. He says, "Look, I hear that you as the questioner are going through a theological crisis. The questions that you have are really, affecting your lifestyle." And he says, "I heard, Rachman al-Islam, that you're no longer putting on tefillin because of these questions." So the Lubavitcher Rebbe's first answer, he says, there should be no connection. Naaseh comes before Nishma. We may have questions in life, and I'm going to deal with your questions. And we're going to have an educated discussion about them. But questions don't affect action, meaning you need to carry on your religious life. That shouldn't impact your Naaseh. Naaseh came before Nishma. As he says, I was especially surprised, according to the report, that that said the problem is bothering you to the extent that it's trespassed upon your daily life as a Jew, interfering with actual fulfillment of daily mitzvahs. I sincerely hope that impression conveyed to me is an erroneous one. Meaning, number one is, we can discuss these things, and there's lots to discuss, but that doesn't impact our life. That doesn't impact the way we fulfill the mitzvahs. We need to just create a dichotomy over here in terms of appreciating and doing what we're doing. Number one, in terms of priorities. That's without even addressing the topic. And let's go a little further. Attitude towards science. Rav Moshe Mazelman, he has actually just put out a book recently called Torah and Science, also well worth the read. He's dealing with more of the age of the universe than the evolution side of things. Nonetheless, this is an interesting point he makes. And that says, the issue is not a new one about the age of the universe. It was first discussed in our sources in medieval times about the world being kadmon. Ever since Aristotle's science has claimed that the world had no beginning. That means to say the world always existed. That was a Greek philosophy. His attitude was that the world has always existed as we see it today. In more recent times, Newton's laws, together with Laplace's work, seems to have proven this conclusively. Neither the philosophic scientific proofs of Aristotle, however, nor the scientific proofs of Newton and Laplace moved our Masorah. None of the Chachmei Masorah who confronted the issue ever suggested that the received position be reevaluated. The received position be reevaluated. Creation ex nihilo has always been remained a fundamental belief. The scientific approaches has always been simply rejected, even in the face of so-called proofs. Remember, the Rambam is also an Aristotelian Talmud, right? The Rambam learned so much from Aristotle. Nonetheless, the Rambam spends a huge amount of time in Moreh Nevuchim trying so hard to prove that, in fact, the world had a beginning point. You can imagine you have to imagine what the Rambam would have given to have been in the 1960s when conclusive proof was shown that there was a starting point, that there was a Big Bang. You imagine what you imagine the nachas the Rambam must be getting when science finally caught up and proved that in fact the world had a beginning point, as opposed to Greek philosophy, which argued and as substantiated throughout the centuries by science that there was no beginning to the world. But his point is a very, very salient point, is that we never at any point in time said, oh, you know what? Oh, that's what Greek philosophy says. That's what science says. So let's sort of reevaluate Judaism. So no, that wasn't a problem then. And this doesn't present this new theory doesn't present a problem now. Meaning, we have constants, right? Ex nihilo, the fact that Hashem created the world from nothing, is a constant. That's one of the bases of belief. So our attitude shouldn't suddenly be, oh well, we need to sort of recheck the files now. That's number one. I think this is a very important point to bear in mind. This is not new. It's not like, oh wow, suddenly I'm so glad Darwin brought this to the table. There's been lots of problems with science and Torah all the way throughout the centuries. It didn't stop Judaism from working. And the Rambam himself clearly addressed this. We did not reject Judaism. So that's before we would address this. Now, so this is an important point. This is what the Lubavitcher Rebbe brings up. He says antecedents and consequence. Okay, so let's take this as a simple example. 4 divided by 2 equals 2. Fantastic, great. So if you take a look at the sum, we have what we call the 4 divided by 2 is called an antecedent, and the 2 at the end, the answer is called the consequent. Right? Fair. So if we do the following, let's say we remove the consequent. All we have is the antecedent, antecedent or antecedent, whichever way you want to pronounce it. Let's remove the consequent. So all we have is 4 divided by 2. How many possible consequences are there? So in the rational numbers, there is only one answer, right? If you're dealing with rational numbers, we're dealing with 4 divided by 2, we only have one answer, which is 2. Fantastic. What happens if we do the other way around? What happens if all we have is the consequent, we don't have the antecedent? So we have 2. So the answer is, so the question now is, what led to 2? So what's the answer? Infinite. It's infinite, because it could be 4 divided by 2, it could be 4 minus 2, it could be 5 minus 3. It could be 6 divided by 3. It could be 10 minus 8. It could be 10 million minus. Let's try to do this. You get the point. Right? The point is that if all we have is the end result, which is the consequent, there are numerous ways to get to that result, to the consequent. So the Lubavitcher Rebbe points out, in all humanity, you started looking at the world, and in the last 200 years there's been a burst of science, and now we've suddenly got a whole lot of information. We've got lots of observations, which is what we started with. Okay, but that doesn't mean to say that because we've got the 2, we know conclusively where the 2 came from. You understand? Meaning we see this diversity enough, we see there's a lot of common shared properties enough, we see the fossil record. But folks, we're talking about discoveries made into the span of, let's call it, just to be generous, 200 years. According to our calendars, there's 5,000 years to deal with, almost 6,000 years. And in scientific theory, we're talking about at least 15 billion years. So, from our little atomic sliver of 200 years, now we're going to draw conclusions as to how it all got here. So you've got to be a little bit careful. He says even further than that. There's 2 forms of trying to understand something we don't know. There's interpolation and extrapolation. Interpolation is where, let's say I have 2 numbers on either side of an equation, and I'm trying to work out the rule for in between those 2 numbers. So I interpolate, right? In statistics, you do this all the time. So you interpolate and you work out what the rule must be, what the specific number is between those 2 numbers, right? When you're working with tables and probability theory. What about if you're trying to work out something else? What if what you're looking for is not within 2 numbers, you're just trying to look at something beforehand. So now you need to induce, you need to extrapolate what is going to be the rule there. Well, that's fine, but the further you get from your set of known variables, the less sure you can be. So let's say I know that I know what happens to water at 100 degrees Celsius, and I know what happens to water at 0 degrees Celsius. So I can interpolate what's going to happen to it at 57 degrees, because that's within the range. But what happens if I want to understand what's happening to water now, let's say at 1,000,000 degrees? or we can surmise and we can say this is the rules we know in this little span over here. But the further we go from what we know, the less likely or the less sure we can be that the rules hold true. Which is, when you come down to what happened with Einstein, meaning Newtonian laws held until you get close to the speed of light. So I mean to say, let's just, with a little bit of humility beforehand, let's consider maybe there are other options as to how things got to where they are today. How we got to the two. That's the Lubavitcher Rebbe's first point, which is a very fair point. We'll see in fact that there are many scientific options of consequence. So the Lubavitcher Rebbe says a very important thing. I urge you, don't take my word for this. Read the entire thing. It's really worthwhile, the entire letter. But here's people make specific quotes and then you sort of argue with people based on a specific quote. It's much more sophisticated than this. But he offers another antecedent, which I'm sure you're all familiar with. He says, even assuming the period which the Torah allows for the age of the universe is definitely too short for fossilization, we can still readily accept the possibility that God created ready fossils, bones or skeletons, for reasons best known to Him. Just as He could create ready living organisms as complete man and such ready products as oil, coal, or diamonds without any evolutionary process. So what's another antecedent? He knows what's another way the equation could lead to 2? Is maybe God created the equation as such. Maybe God created everything, all the evidence as such. And this is a very well-known theory that is forwarding. It's not only him who suggests this. There are a number of questions on this particular theory. But let's just be fair for a moment. This is 4 minus 2 as opposed to 4 divided by 2. This is another way of getting to the same answer of what we see today. The questions that are asked on this particular theory is, why would God do that? I'd like to come back to that in a moment, meaning what would be the agenda of God for tricking us, number one, which he tries to address he addresses in the next paragraph. And number 2 is, there's another issue with this particular theory is what science will call this is not falsifiable. In scientific theory, you need to be able to falsify, in order to be able to believe anything scientifically, you need to have a hypothesis, a null hypothesis, in which you can say, well, you can reject it if there wouldn't be another alternative. Here, you can never reject this because whatever you see is going to be part of that creation process, which is not necessarily a problem because the Torah isn't a scientific document. I mean to say, the theory that the Lubavitcher Rebbe is affording does not need to be falsifiable because we're not dealing with science. Nonetheless, I would like to leave that question on the Lubavitcher Rebbe, why Hashem would do this. But nonetheless, let's think about the following. Imagine that you have there's a murder case, and somebody's found Rahman al homicide in their house. The knife is left there, covered with blood. There's fingerprints on it, and it's the neighbor's fingerprints. So he is brought into court, and as a defendant, he says, Your Honor, I'd like to tell you, the jury, I have to tell you that it's planted evidence. That knife, it wasn't me. I had nothing to do with it. So the judge will say, well, I'm really sorry, Tom, but you have the fingerprints. It was the weapon of murder. There's not much to discuss over here. You're framed. Don't. If there's smoke, there must be a
smoking gun.
Right. There's smoking gun. With circumstantial evidence is so much. The preponderance of evidence is so much. There's not much to say. However, what happens if the following happens? Now it's not so clear. You see, Tom was actually away the night before, and he got back from the airport just early that morning, and so it's not even clear if he could have arrived at his house at the time. Number 2, in fact, the two of them were very close friends. In fact, Tom had a meeting at the same time in the city at the same time. There were numerous other variables in the equation which make it look a little more difficult for Tom to actually have been there at the time. Now Tom gets up in court and says, Your Honor, I'm sorry, the evidence was planted. Well, the more questions there are on the circumstances in the first place, the more that argument has credence. So the Lubavitcher Rebbe is saying is the evidence was planted, meaning, right, we look at the fossil record and, why is it as such? Well, it was planted. So the more questions we have on the theory in and of itself, the more likely this leads credence to this particular idea. So here's some other questions, doubts about the theory of evolution. Let's take a look. First of all, honesty of the scientific process. Rabbi Victor Miller has a book called Sing You Righteous. He spares no words for science. Rabbi Victor Miller is ardently opposed to evolution. If you want to read this, it's not just fly-by-the-night arguments. He's done a lot of reading. Very worthwhile to read. It's very, very anti-science. He says the following. He says, here's an example about, let's say, the development of humanity. So he says, I'm just going to actually pull it off of my notes. It's a little easier to read here. He says, he's talking about the discovery of Neanderthal man as an example. So he says the following. He says, But that skull was not found in one piece. It contained 400 fragments, and those fragments were not in one place, but were chosen from tons of debris, were put together at the discretion of persons who stand to gain by the most of such a discovery. Those persons who had invested hope and hardship to sacrifice in the search for the world's earliest man were the sole judges of which of the minute fragments to accept or reject, and where to fit them in. The entire episode was as biased as could possibly be, and the report was crowned with a portrait of an imagery of a man who appears as ape-like as possible. But this man, even as creators admit, was a maker of implements which show a remarkable consistency of design, according to National Geographic, which means that he was a true human of the same kind as all other men. Then this myth is supported by nothing but the desire that it be. And he goes on to say that the dating of those bones was not done on the dating of the bones themselves, but by the fossils that were found in the area around that particular fragment. Meaning to say, when you go to the museum, you're looking at all these ape-like human beings. If you go to the Museum of Natural History, how do they know what they look like? Meaning to say, we've superimposed the skin based on the jawbone that was reconstituted from 400 pieces. So meaning to say, it's okay, you can get to what that jawbone must have meant. But first of all, who was putting that jawbone together, number one? And number two is so why do you make it look like that? Meaning to say, what type of form did you superimpose on that person? How much hair did you give to that Neanderthal that makes it fit into the theory that you're going to try to advance? Meaning, how honest are we about the process? Which pieces did you not include in the reconstitution of that skull? Just a very interesting point in terms of the scientific process, which I think is a very valid point. You need to think very carefully. How much are we? Is this suddenly you discovered and boom, in the cradle of humankind in South Africa? How much is there? How much evidence do we have? More than that. Gaps in the fossil record, very, very, very important to consider. Rabbi Victor Miller points out the following, and this is not him. This is many, many people in his campuses. He says it very succinctly. He says the most definite information containing the history of evolution of plants and animals has been gained from the examination of fossils found in the rocks. This is the unanimous opinion of evolutionists. The best proof is the fossils, but the fossils themselves are the clearest evidence against evolution. The plain truth is that there's not even a set of fossils to support even one of the supposed evolutionary lines. Darwin was mystified why we do not find in the fossil record graduated varieties between the allied species. And he sought to explain them away by the incompleteness of the fossil evidence. He prophesied that these troublesome gaps would surely be filled by research. But 115 years have passed since the prophecy. During this time, a great search of fossils has been carried on all over the globe, and countless fossils have been unearthed. Yet the transitional forms are still missing.
The missing link.
These are what we call the missing links. When kids in school say you're the missing link to their friend, this is what they mean to say is that we see lots of different species, we see lots of different creatures, we don't see the in-between creatures. The fossil record doesn't have the creatures that change, the in-between creatures which change to the next level, the gaps in the fossil record. Which, by the way, if you want to just appreciate this in terms of the process, if you're a fan of gradualism like Richard Dawkins, that means that things moved slowly and incrementally. So let's say we have a few thousand years for this, water-based creature now to become a land-based creature. So slowly its flippers are going to go just a little bit longer, just a little bit longer, just a little bit longer, right? There's going to be a certain point where it's going to be a very ineffective fish and a very ineffective land animal. And at that point in time, it should all be killed and they should never exist anymore. I mean to say the idea of gradualism, that suddenly, that over the period of time we're advancing is, in the end of the day, that's a dead duck halfway through the process, right? And which might be why there's no fossil record, but then how did it happen, right? If we think about it as a gradual process, which, by the way, so science has dealt with this, we're going to deal with this a little bit further, so Stephen Jay Gould has advanced a theory which is now taught in text, which is called punctuated equilibrium, which means that what happened in evolution was that it wasn't gradual. What happened was that there was long periods of very, very subtle change, and suddenly there would be a very, very intense period of change, and then gradual change. I mean, it was punctuated. There were periods of immense change, and the reason why we don't have fossil records for the change periods is because they were so short. Which is fine. But now let me come back to the Lubavitcher Rebbe's question, on the question of the Lubavitcher Rebbe again. People say, why was it that God would have created the world, with a fossil record? Let me ask you a question. Why would it be that God created a world that there's punctuated equilibrium, that everything moves suddenly fast and suddenly slow, suddenly fast and suddenly slow? Right? You understand? Why the fossil record? Why is the fossil record missing? That's, you understand, there's questions on both sides, just to appreciate things, right? It's a very unusual way that things work. I'd like to come back to him next week. I'm sorry, just for the sake of time, I need to go and move a little further. Other examples. No recorded mutation from species to species. Dr. Gerald Schroeder, he writes a lot about the age of the universe. we're dealing with more evolution. But listen to his point. The British Natural Museum and History Museum in London has an entire wing devoted to the evolution of species. And what evolution do they demonstrate? Pink daisies evolving into blue daisies, small dogs evolving into big dogs, a few species of I don't know how to pronounce it. Anyway, cichlid fish evolving into a mere few thousand years into a dozen species of cichlid fish. Very impressive until you realize that the daisies remain daisies, the dogs remain dogs, and the cichlid fish remain cichlid. It is called microevolution. This magnificent museum, with all its resources, could not produce a single example of one phylum evolving into another. It is the mechanisms of macroevolution, the change from one phylum to a class of animal into another, that has been called into question by this data. Do you see what he's saying? I mean to say, it's fine, we can see it in the lab, we can see bacteria evolving. We can even see finches evolving to the point where they can't mate with each other. But have you ever seen a fish turn into an animal? The fossil record doesn't have it. And when you see the evolutionary process, we don't have any proof for it. So just to bear in mind on the scientific level, we're theorizing about what happens. We don't know what happens. More than that, just to give you a sense of the degree of improbability of the rise of life, Bill Bryson, he's very much in the evolutionary camp. He talks about trying to understand how it was that life came into being in the first place. Okay, so this, by the way, is not really fair to put in the same camp as evolution, because evolution really is life forms. Nonetheless, people like Richard Dawkins will include this in the evolutionary process. So I think it's fair to point this out. He says the chances of a 1,055 sequence molecule like collagen spontaneously self-assembling, meaning turning into a protein, which is the first form of life, are frankly nil. It just isn't going to happen. To grasp a long shot, what a long shot its existence is, visualize the standard Las Vegas slot machine. Let's try to think. I know we've never seen anything like that. So but broadened greatly to about 90 feet, to be precise, to accommodate 1,055 spinning wheels instead of the usual 3 or 4, with 20 symbols on each wheel, one for each common ammonia acid. How long would you have to pull the handle before all 1,055 symbols came up in the right order? Now, folks, I don't think any of it. Effectively forever. Even if you reduce the number of spinning wheels to 200, which is actually a more typical number of ammonia acids for a protein, the odds against the 200 coming up in a prescribed sequence are 1 in 10 to the 260. That is 1 followed by 260 zeros. That in itself is a larger number than all the atoms in the universe. Just to understand how improbable that is. And therefore, in his next paragraph, which I quote, he says, which is why we have a lot of time, because in 15 billion years, even the improbable is plausible. Okay, so meaning to say, that's why time gives us the ability to be able to get to that point, which is what he argues. But nonetheless, just appreciate the statistics over here. Now, let's take it further. Dr. Nathan Aviezer has a book called Fossils and Faith, many books actually, and he at the end of a particular chapter, his conclusion is the following. I wish to emphasize that no one is attacking Charles Darwin. In 1859, Darwin formulated one of the most important theories ever proposed in biology, accounting admirably the best scientific tradition for evidence known at that time. By 150 years have passed, the store of knowledge has vastly increased. The new non-Darwinian ideas have taken their place upon the scientific age. Men like Kimura, Alvarez, Robb, Anderson, Kadanoff, Kaufman, Gold, Stanley, and Bach are the serious scientists of the first rank. When they tell us that Darwin's theory is insufficient to explain the important aspects of the evolution of the animal kingdom, we would do well to lay aside our biases and listen. It is time to move forward indeed. And he actually lists other theories which also explain the two. Impact theory, neutral molecule theory. There are other theories which haven't made it to mainstream science and have been ignored essentially. Whereas Darwinian gradualism has taken the 4 on the table. So his point is that there's other ways of arriving there as well. This is by the way, here's the chair of physics at Bar-Ilan. Okay, so just to realize why it is that other theories don't get there, coming back to Rav Miller, the so-called scientific society is a body of men who follow religion of their own, with their own traditions. Anyone who ventures to question their generally accepted theories is subject to scorn and persecution. When a scientific writer of a considerable ability appeared with new ideas, some of which were subsequently substantiated, the college scientists threatened to boycott all of the publisher's textbooks, and the writer had no choice but to seek a publisher who was not in the textbook business and could not be coerced by academics. Men who sympathized with his idea were deprived of their jobs, and other persecutions were visited upon them. A flood of frenzied invective were poured upon the writer. The vaunted objectivity of the savants is reserved for those who subscribe to their own religion. So we just say, how can we be sure that we're getting the truth when there is a defensive nature as to what really is being proliferated in this? Which is why, at the end of all said and done over here is in this camp of thinkers, we have to take the whole theory itself with just a little bit of grain of salt, just be a little more humble in terms of how we could have possibly got here. And now we can return to the Lubavitcher Rebbe. The Lubavitcher Rebbe told us, remember, that maybe the way that we see the observations, the consequent, what we're looking at now, could have arrived in another way. How so? Could have arrived, and maybe it was planted evidence. Maybe Hashem created a world as such. And you say, really, the circumstantial evidence seems to be pointing in one direction. Well, after we looked at it a little bit today, the fact that maybe the scientific process is not as honest as it could be. Rabbi Avigdor Miller was talking about the skull. There was the jawbone which was reconstructed from 400 different pieces. And he carries on to mention, by the way, Derech Agav, the idea that the vestigial organs which we call useless, for instance, one of them until very recently were the tonsils. We called them a useless organ until we actually realized that in fact they played a very important role. Many of the organs that we said were vestigial and useless organs we actually have been finding uses for. So we have to be very, very careful about that. So if the honesty of the scientific process we questioned, the gap in the fossil record, where we don't have the transitional creatures, why would it be that something is speeding up in that process? We talked about how we have no recorded mutation from species to species, from phylum to phylum. We talked about the degree of improbability of the rise of life, and many other scientific theories, alternative suggestions as we to gradualism as we got to today itself, and the intensity of the scientific world against people who have alternative suggestions. So now at this point in time, the circumstantial evidence is somewhat cloudy. It's not as incandescently clear as it would appear at the beginning. So now the question is the Rabbi Rebbe says, who's stopping us understanding that Hashem made a world as such? And you say, well, yeah, you're right. It's actually not so simple. It's not so clear as some of the scientists would like to imagine it to be. And if you want to take this one step further, just to appreciate this in fuller context, the Lubavitcher Rebbe asks himself, why would it be that Hashem would create such a world? And he says, the Lubavitcher Rebbe said, well, why would he create a world? Why would he create an atom in the first place? If you want to dig it one step deeper, and with this we'll perhaps close. You have to understand, as there was an explosion of science and understanding in the world, as we got to degrees of sophistication of understanding the universe on the macro and the micro level, which was roughly in the last 200 years plus, in a certain sense, we would have a blinding sense of awe of the watchmaker theory of William Paley. The more sophistication we see, it would be almost as if there is no choice other than to believe in God. And throughout history, there's a notion of zel u'mazeh. Hashem always creates a balance. Rav Yaakov Kamenetsky talks about this in the beginning of Parshas Va'era, where he talks about how prophecy and Avodah Zarah are counterbalances for each other. When God was very imminent through the mouths of the prophets, there was this Avodah Zarah. It's brought down by Gra in the footnotes in Seder Olam. And therefore, in the times of the Gemara, Rav Yaakov Kamenetsky talks about the times there were holy individuals, there were also shadim, and as there's a diminishing in the tzara tov, on the balance of good forces in the world, there's also a diminishing of the evil forces in the world as well. Why? Because people have to be in a place where they need to make rational decisions as to believe in God or not, and they need to have a decision on either side, a power on either side. As there's an explosion in realizing in complexity, the beauty of nature everywhere around us, and the watch becomes much more infinitely complex, at the same time, suddenly we're discovering an alternative. Because maybe Hashem left it that way. Maybe Hashem planted the evidence in such a way that we would discover it concurrently with the complexity that we're arriving at, in order that there be an alternative, in order that humanity have to make the choice and have to sit down and think hard and say, well, is this the way to discover Hashem? Or is there another way? And because we have that alternative, because we have that opportunity of making a decision, that's what the schar is for really making the decision to see God. Because there is an alternative which, according to some, would seem plausible. Because we have that bechira to recognize God and to be astounded by God as we look into the world around us. The Lubavitcher Rebbe concludes and he says, needless to say, it is not my intent to cast aspersions upon science or to discredit the scientific method. Science cannot operate except by accepting certain working theories or hypotheses, even if they cannot be verified. Though some theories die hard, even when they are scientifically refuted or discredited. The evolutionary theory is a case in point. And so I mean to say, I'm not disagreeing with the work of science, but the point is that we need to just we view it in a balanced perspective. What I want to say is that coming to a conclusion on this particular part of the arm of the shear, this is a idea, and these ideas in this particular camp resonate with a lot of individuals. And in fact, the more yeshiva world is more oriented towards this particular idea. I feel that it requires a lot of energy, because when you're in a collision, which is what the two theories are over here, there's a lot of energy spent trying to explain on both sides. Next week, what we're going to try to do is we're going to try to work within the synthesis camp, where we try to see that maybe, in fact, that science and religion aren't, in fact, in contradiction at all. There might be a lot more that they work together. And there's a lot more energy spent in terms of, we'll call it synthesis energy, rather than collision energy, which is what we spent doing today. Once again, it's important to realize that different people resonate with different ideas. I'd like to just conclude with a particular cartoon that I saw recently, where there was a picture of two snowmen talking to each other, and the one snowman says to the other one, he says, "What do you mean? What do you mean somebody created us? We evolved from snowflakes." which is perhaps a very interesting summary of this particular thing. We're looking forward to Mr. Hashem next week to continuing the synthesis.